wonderful learning individuals. It is a pleasure. How are you all doing today? It is so great to have you. Thank you also so much for pressing the play button. I am Johnny, your host with HomeCountry Mathematics. Please feel free to stay to also learn because mathematics can really be fun. Now, let us learn some maths together, shall we? Alright, guys and gals, as usual, welcome. Thank you for stopping by, learning along with the channel. That is so great. We are continuing on with Unit A, Section 1-3. The topic is operations with fractions, multiplying and dividing. Let's go. This is so much fun. Fractions, multiplying and dividing is so easy. I love this. Okay, so we're going to talk about what is called the reciprocal. Okay, when you're multiplying fractions, there's not really much to do other than just simply straight multiply the numerators and straight multiply the denominators. Again, they are separate of each other, so you only multiply the numerators together and you only multiply the denominators together, okay? When we are multiplying fractions. Okay? So in this case, quickly, the answer would be 2 over 15. Okay, let us continue. Now we're kind of leading towards dividing and division. What do you have to do? What are the steps to take to divide fractions? You wouldn't believe how easy it is. Okay, it's just an extra step and it's pretty minor. So let's talk about what we have to do. Two numbers whose product is 1 are called multiplicative inverses or reciprocals. Let's talk about reciprocals, okay? So we have a fraction 3/8. All right? And what they're talking about is if you multiply it by its reciprocal, the reciprocal is essentially just flipping the fraction. That's all it is. Okay, so when you hear reciprocals, just think, flip the fraction. Okay, there we go. Flipping the fraction. And those of you that have been following along and learning along, you are all great. I absolutely love it. You can see here we could do two things. We could not notice, right? What I mean by not notice is the canceling part, right? If you just go straight to multiplying, you might go, oh, silly me, what was I doing? As you know, 24 divided by 24 is going to be 1. Right? We didn't need to do this. We're moving forward when we didn't really need to. If you actually notice right from the get-go that we could actually do our canceling. This is kind of called canceling. It's all part of the factoring, right? So 24 over 24 does equal, in fact, 1. Okay? But what if we had, I don't know, this this was our answer, okay? We know the same number divided by the same number is divided by 1. Let's talk about factoring quickly. What is factoring? Really what we're doing is finding common numbers between the numerator and the denominator, okay? I don't know, we'll just go with this, okay? This is just an example. It's obvious our numbers are right here, 3 and 8. 3 is going to be our common because we know 3 divides by 24. And saying it again, 3 divides by 24. This is all blah, 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 blah. This is all part of the factoring process. Okay? That's factoring in a nutshell. Well, normally we would have different whole numbers, you know, for our numerator and denominators, but just to quickly show you as an example, we will do more factoring and reducing in the future, okay? So that's the reciprocal, okay? I could have 4/5, right? Let's say the question is multiply it by its reciprocal, right? So that would be 5/4. Again, it's the same thing. We can cancel. When you have a numerator that is the same as the denominator, exactly the same in value, you could just cancel them. Because what does 4 divided by 4 mean? It just means 1. Okay? Any value multiplied by 1 is just going to give you the same value. Alright? That's reciprocals in a nutshell. So they have one here that is 2 and 4/5. Again, the question is multiply it by its reciprocal. Let's say, you know, that's what they want you to do. Of course, we have to convert this to an improper fraction. Okay, this is a mixed fraction, and we need improper. That's easy. We just take the front whole number, multiply it by the denominator. Okay, that gives us 10. Okay, the second step is to add the numerator. Okay, which equals 14. There we go. That's how you figure out your numerator. So, numerator is going to be 14. Denominator is always unchanged. Multiplying it by its reciprocal is simply just flipping the fraction. It's copying it and flipping it. Okay? And of course, we're going to know this all cancels. And our answer is going to be 1. Okay? Let's get into some real stuff. Alright, that's reciprocals. What is a reciprocal? It's the flip. Flipping the fraction. Find each quotient. Okay, here, let's get into some real problems. 1/3, and they have divided by 1/2. Okay, I'm not a fan of linear type fractions or division. Not a fan. Normally, it should be written like this. Okay, that's what we're doing. So why the reciprocal? Well, what we're doing is we're taking it from down here and we're bringing it up. Okay, when we do that, this is why we're multiplying So when you're dividing fractions, you're actually multiplying the left value, the left-hand side. Well, I guess it's north and a south now. I should correct myself. Okay, we have a north. We have a north and a south. Okay, and we're bringing the north up to the south. What? Let's do that again. I need more coffee. Hang on a sec, please. All right, I'm back. We are bringing the south up to the north. South up to the north. In doing so, what we're actually doing is this. 1/3 times. Flip the fraction 2/1. So that's dividing fractions in a nutshell, guys and gals. Again, we've already done multiplication of fractions, right? You simply straight multiply the numerators together, which is 2. Straight multiply the denominators together, which is 3. And there's our answer. 2/3. Let's see if I can show you something here. So let's say let's do this. Something that we're kind of used to. Imperial type fractions or baking, cooking type fractions. It might be written like this, okay? What is happening, if you notice what we're doing is we're taking 0.5 and we're dividing it by 0.25. If we turn it into decimal form, right? That's what we're doing. We're essentially, so we know that 0.25 is 1/4, right? Okay, so if I write this the way I like to see it, I like to get into the habit of writing division, like this division symbol here. I like turning it into, this is what I call linear form, and turning it into actual, the way it's supposed to be written. I recommend mathematical problems always be solved in this form, because as you start advancing, you'll see, okay? So again, what we're doing is we're bringing the quarter to the top. Okay, so when we do that, we get 1/2. And if you notice, we're now multiplying it by 4. See the difference? When you divide something by a quarter, you're actually doubling the original value. Well, in this case, quadrupling. Well, we do the math, we end up doubling. So we do essentially double. As you can see, 4 divided by 2, right? If I put this together in fraction form, we're actually getting 4 divided by 2. Okay, you can see that. I just merged this. 4 times 1 is 4. So we're doubling in a sense. You can see that. I was correct in saying doubling, because that's what we're doing. Yeah, I'm multiplying it by 4, but we're multiplying that 2, or that 4 by 1/2. What's half of a 4? Well, that's 2. So notice these subtleties, right? When you divide something by a quarter, I'm just doing this as an example. right? You notice how the original value increased? That's kind of what I'm trying to get you to see, right? When you divide something by a small value, or a quarter, for example, you're actually doubling it in the sense. In this example, that's what we're doing. Okay? You see that logic? There's our answer right there. It's 2. And you could check it on the calculator if you like. I want you to see that, have that visualization and understanding, okay? So, let's do another. Let's just keep doing more. 3/8, common imperial fraction, divided by 2/3. Writing it in, I'm not sure what to call this form. Of course, I'm going to have a longer, I like to make it longer just for that separation. And we're dividing by 2/3. Again, the logic is we're bringing the south up to the north, and when we, in doing so, we're actually multiplying it. Flipping 2/3 is 3/2, which equals 3 times 3 is 9. 8 times 2 is 16. Can we reduce? Well, we know 3 times 3 is 9, so that's not a prime number. We know that. Same thing with 16, which is 4 times 4, or 8 times 2. We don't have any common numbers, right? No common numbers. So all we can do is assume that we are done reducing. Okay? 9/16. Let's do another. So it's not so scary now, right? Now that you understand, right? You're still multiplying fractions. In the end, you're still multiplying fractions. Originally, we're dividing, yes, but, you know, let's make it easy. So they have 4 divided by, I'm just going to write it the way they have it, and then turn it into my own form. 4 divided by 5/6. What does 4 mean? Well, 4 is the same as writing 4/1. Okay? We can turn any whole number into a fraction. It's that easy. 4/1. Divided by 5/6. Let's bring the south to the north. I know it sounds funny to say, but that's what we're doing. We're flipping, right? South to the north. In doing so, we are actually multiplying the north, which is the original value, multiplying it by the reciprocal of the south. Okay? 4 times 6 is 24, or 6 times 4, because that actually rhymes. 5 times 1 is 5. We could turn this quickly into Right now it's an improper because the numerator is larger than the denominator in the sense we could turn it into a mixed. So we need to get close to 24 without going over. 5 times 3, 5 times 4, 5 times 5. All right, looks like this is our answer right here. 5 times 4. Because 5 times 5 is 25, that's greater than 24. We're going over. We don't want to go over. 4 is our front whole number. The next step is to take that 24 and subtract it by, what's 5 times 4? That's 20. That leaves us with 4. There's our numerator. And our denominator always unchanged. There we go. There you go. I appreciate you so much. Thank you for watching and learning along with the channel. You are great. Every single individual that's watching and learning along, we all support you. Good luck in your studies. Let's go. I will see you guys and gals in the next video. For now, take care.